We're going to be working on another quadratic here. Again, this quadratic is going to fit nicely with my quadratic equation. However, it's going to have a less nice radical. So let's go with 24x squared minus 11x minus 14, and all that equals 0. So since this all matches up, I'm ready to find my roots, which is the solution to my quadratic formula. So I have a equals 24, b equals negative 11, and c equals negative 14. Again, you should always have your quadratic formula written and your empty quadratic formula waiting to be filled with your variables. So your b should go here, so I need a negative 11. Notice how it's a negative negative now, because it originally was negative b. So I have negative 11. Then I drop a negative 11 in here as well. Now this is 4 times a, which is 24. And b, or c, is negative 14. So I would drop a negative 14 in here. And on the bottom here, I'm going to put a 24. So now if I want to clean this up, the next step is to rewrite everything. I have x equals, well, negative negative makes a positive 11, plus or minus square root of something, over 2 times 24 is going to be 48. So now we just need to figure out what goes in here. So I'm going to take my calculator and I'm going to plug in exactly what goes there. So let's clear, and I would have parentheses negative 11 squared minus 4 parentheses 24 parentheses negative 14 end. And this right here is going to give me 1,465. So let's go ahead and drop that right in here. 1,465. Now 1,465 doesn't actually have any nice square roots. So take the square root of 1,465 and we're going to get this number. So if we want to simplify past this perfect level and we want to get an estimation, then we're going to have to use that decimal. So I would say this is equal to 11 plus or minus, and that was 38.27, 53, and 18. That should be enough decimals to keep it accurate. Now I can estimate my x1, which is going to be with a plus, so I'll have 11 plus my 38.27, 53, 18, all over 48. And I'm going to have my x2, which would be the minus. So minus 38.27, doesn't look like a 7. So 53.18. The reason why I keep so many decimals is until the very end, when it asks you to round like to the nearest hundredth or to the nearest tenth, you really need to keep a large accuracy. Before I actually can put this into the calculator and do this in one step, there is a rule that says when I have fractions, I need to put parentheses around the top and around the bottom, always before I do that division. The first division I'm going to do is parentheses 11 plus 38.275318, close parentheses, and divide by my 48. And I get 1.0265. So 1.0265. And this next one, let's go ahead and plug that in. I'll get parentheses 11 minus 38.275318, close it, divide by 48. Hit enter, and I get negative 0.56823. So 56823. 56823, and that was a negative 0.56823. That's x2. What if the problem says I need to round to the nearest, let's say, 100th? So if I want to round to the nearest 100th, I find out this is my first, my ones, this is my tenths, and this is my 100ths. So you have to ask yourself, what is this guy doing to influence my 100ths? And since he's bigger than 5, I'm going to round this 2 up. So my x1 would be 1.03. That would be my final answer rounded to the 100th. And over here, I don't have a ones column. I just have a tenths column. I have a 100ths column. And I have to ask myself, what is this guy doing to my 100ths column? Is he going to round up? And yeah, it's an 8, so it's going to round that up. So my x2, or my second root, would be negative 0.57. This would be the 2 roots to my quadratic equation. 24x squared minus 11x minus 14. It will have an x-intercept at 1.03 and at negative 0.57.